This talk is about converting from Maven to Gradle. This is something that Elasticsearch, the project that I work on, did last year. It's a story. This isn't going to have a lot of technical details in it or anything like that. If you have questions at the end, I'm happy to answer them. But this is just something kind of light-hearted kind of explanation of the tribulations that we went through. So what is Elasticsearch? This is a distributed RESTful search engine. It's been around for 6-7 years now, something like that. It was created by a guy named Shai Bannon. It's built on top of Lucene, Apache Lucene. It's an open source search engine. And we have a number of plugins that we officially maintain, a pluggable architecture so that other people can plug in their custom things, for example, for node discovery. So how do nodes find each other? They want to find each other in AWS or Azure or Google Cloud Engine, or Google Compute Engine, excuse me. You can find the code there on GitHub. How big is it? How big are we talking? About 5,000 lines, 5,000 files, 500,000 lines of code. We have 21 official plugins if you count our commercial plugin that we add in, and then about 150 dependencies. So it's a relatively sizable open source project. So where have we come from? It's actually funny, we actually started with Gradle. So back in 2008 or 2009 when, 2010, excuse me, when Elasticsearch was first created, it used Gradle. And so we started back then. It was around Gradle 0.8. It was a completely different world back then, the Wild West. So there was no Ide support back then. And so the way that this was done is these Ide files for Eclipse and IntelliJ were checked in, and they were configured to point directly into the Gradle dependency cache. And this was all okay for a while. All the plugins, these official plugins that add extra functionality into Elasticsearch were part of the same Elasticsearch repo. And this worked okay for a while, for about 1.5 years, up until version 0.19. And at that time, Gradle changed how it did dependency caching, and it started changing the file names with like a hash in it. And so you couldn't figure out what these file names were going to be anymore. And so Shai said, okay, we can't do this anymore. And with some help from some of the people, he switched to Maven. And so then in Maven, he knew about the problems, he says, that Maven multi-module had. So he did not want to use Maven multi-module. He split out all of the plugins into separate repositories. And so now then there were 20-something repositories on GitHub that all had to depend on core in some way. So they used Maven snapshots. So Jenkins would publish core, and then the snapshot would depend on that, or the plugin would depend on that snapshot for its build. And so we have 20-something different builds that are depending on talking to Maven Central. This was okay for a while, and then when we started getting ready for 2.0, a lot of people thought that the build was kind of like this in Maven, but in actuality it was like this. So we had lots of problems. The people that liked Maven, it was great for them, but for the rest of us, it was problem-ridden. So what are those problems? Well, the snapshots were the main problem. And it's not just with the official plugins that we released, but it was also with our commercial plugins that are private repos. These all depended through Maven snapshots. So doing a build, if we went and tried to change something in the core, we would check that in, and then a couple hours later, build would go red, or Jenkins would go red, because we broke an API and we had no idea that we needed to make a change in one of these other repos. So the plugin builds for Jenkins were just always red. On top of that, we had just jar hell everywhere. So at the time, all of the plugins and Elasticsearch were all in a single class loader. And so if you had depended on different versions, well, it just depended on what order they happened to be put onto the class path when they were loaded. And we really had no way to detect that we had this jar hell. And so we really wanted to have real integration tests where we started Elasticsearch with these plugins, and this was our goal that we wanted to fix. So for 2.0, we continued to work on this system and decided, you know what, we need to move everything back into the repo. We're going to use multi-module. And we had no idea about the supposed problems of multi-module, those of us that were working on it at the time. We tried to remove a lot of duplication when we had every repo as, or every plugin as a separate repo. Each one had, its own POM file and its own entire copy of the setup for testing and everything. So there was a lot of duplication. Everything had its own license files all over the place. And at the same time, we also wanted to add, like I said, real integration tests. This was troublesome because Maven doesn't really have this concept. And we wanted to actually, spin up the server and make sure that the server was spun down when the build completed, because we didn't want 20 nodes of Elasticsearch running off in the background just because we Control-C'd build. So what we ended up doing was using Ant for this. So roughly half of our build then became Ant that was invoked through Maven whenever we wanted to do anything that Maven wasn't capable of. And this was quite painful because it was then 2 different XML languages that we had to maintain. But we went along and we had this new Maven multi-module build, and everything was good for a while because now we could make changes to core and we knew that they were going to build. But actually, this is what it really looked like. So it was this very fragile system that if you tripped and pulled a cord, the entire thing could go up in flames. So it wasn't on fire, but it could be on fire at any time. And so with this, we realized, we really need to look at all these problems that we're having with Maven multi-module and figure out first, what do we need in our build? So we had a couple different things at that time. So we had these various static checks. So it's normal static analysis. We have some additional static analysis that's unique to Lucene and Elasticsearch and checking for what's called forbidden APIs. We had license checks both in the header or the header of each file as well as for all of our dependencies. Similar to Apache, we require that all these license files be checked into the code. And then, of course, code style, we checked files for things like no commit comments that we don't want to actually check in. Then we had our unit tests. This was based on a randomization framework that's inside Lucene itself. I'll talk more about that a little bit later, but essentially it has all kinds of extra goodies inside there for checking things like thread leaks and stuff like that we want to make sure we're not doing. And then finally, we needed to be able to run these integration tests. These HTTP-based, we spin up Elasticsearch, we talk to it over the HTTP API. We had a bunch of different configurations there that we wanted to test. We had also, while in Maven multi-module, added these packaging tests. So a problem that we had in the 1.x days was we had no idea if the software actually ran. So we would build an RPM or we'd build a deb file. We have no idea if it actually works on any distributions of Linux. So we added these Vagrant tests. So all the distributions that we officially support of Linux, we actually ran and installed through our deb file or installed through our RPM file, and then ran various checks that the thing will actually start on those systems. And then something we wanted but that was difficult to do in Maven was mocks. So in addition to running Elasticsearch, we wanted to have these mock services. So like if we have S3 or HDFS or something like that, we want the system to be able to talk to a fake version of that, because actually talking to AWS or S3, we're going to leak all kinds of resources and stuff. We didn't want that. So we wanted mock servers that we could start up just like we started up Elasticsearch in our integration tests, but we didn't have that. And so we then got to the point where we're like, okay, Gradle, this might work. And so now I'm going to kind of go through just a handful of things that we did, the problems that we were having in Maven multi-module, and then how Gradle solved them. So we start out with Maven multi-module itself. Like, what's the problem with it? Well, it was hard to explain, but everyone knew there were problems with it, and the real problem was that Maven multi-module was an afterthought. This wasn't something that was built with Maven originally. It was something that was just tacked on. And so the way that you would think that multi-module works is when you specify a dependency, whenever you build, wherever you are in the build, it's going to go and pull that local dependency because you have multiple modules, right? But actually what it does is it goes through this reactor thing. And so this means that if you're in the wrong directory and the reactor doesn't happen to know about, say, module A, it's going to go download it from the internet, even though you have it right there on disk. This is a fundamental problem with Maven multi-module. And so what that looks like is, so we have our three modules here, module A, B, and C. And if we make a change in module A, normally you would expect if I'm inside module C and I build, then it's going to pick up my changes in module A. But what it would actually do is not know anything about module A or B, go download them from the internet, and then you get very weird results. Now, Maven people will tell you, oh, this is an easy problem to solve. You just run an install. So then it puts module A and B into the Maven cache, and then you CD into module C, and now you can run your tests. Well, let's say you have 16 modules inside module C, submodules, and now each one takes 1 minute to test, and at the end of the 15-minute cache timeout, suddenly module 16 is going to go try to get module A and B, and it's going to say, well, it's timed out of the cache, let me go download it from the internet now. So now your long build that's been running for 15 minutes suddenly fails because it can't find the changes you just made. So like I said, Maven multi-module fundamentally broken. Gradle, thankfully, was perfect. So we started using it around 2.6, right when project substitutions came in. This was exactly what we needed. We were able to use the Maven coordinates so that we could reuse some of the Gradle code. So we used the coordinates instead of project-specific dependencies. And then we set up substitutions for all of our local projects. So this worked great. And the most important thing was that no matter where our shell happened to be inside the terminal, it would know about all of the projects. And so this was just fantastic for us at the time after being burned by Maven so many times. So the next thing are those static checks that I was describing. We had a bunch of them. There were a bunch more that we wanted to add. And so the problem with Maven is that if you don't fit into its model, you can't do anything. So you have to align everything in its phases and goals and everything. And as far as building, it's a strict sequence of phases that are going to run, and there's no place to add your extra random tasks that you want to run. And so Gradle was very nice for this because we could just add these tasks as necessary. And additionally, we wanted to be able to run all of the static checks at once, but without running tests or integration tests. And so we created this pre-commit task. This is something we actually have in Apache Lucene in our Ant build there. And so this allows us to run all of these checks, say, right before you're committing without having to run all the tests. So you ran all the tests and you made a quick little change. You just want to make sure you didn't break anything really bad. And so that's what pre-commit is for. And so we added this pre-commit task that depended on a bunch of other static checks. And then we made it really easy to add new checks too. So this was all set up as Gradle plugins inside build source. And one of our goals with this was to be able to deploy this build source. Excuse me. So we did it inside build source. We actually made it so we could publish build source And so then all of our community plugin authors could reuse all of the Gradle setup that we had done there, and they get all of our pre-commit checks so that we can have a similar code style and make sure we don't use forbidden APIs and such like that. So the next thing was the tests. So like I said, we have unit tests and integration tests. The randomized unit tests are something that's crucial to both Lucene and Elasticsearch. So like I said, this is a library that was originally built inside Lucene and then kind of extracted out into the randomized testing framework. And this is actually used by researchers that talk about software testing. It is like a really, really important library. And so we didn't want to lose this. The most important part about it is this deterministic randomization. So instead of just completely randomizing everything, we fix a seed and we print out that seed on failures. So with a reproduce line that says like, hey, this is the seed that I used, so that we can always reproduce. And we just hammer Jenkins day and night. Not based on every commit, but simply when the last build finishes, we start running the next build. And so this randomized testing framework was something we wanted to continue to use, but it only worked in Ant and Maven. And so we needed to figure out how to integrate this. So what it did was, thanks to the ease of using Ant from within Gradle, I was able to actually just call to the Ant task, wrap it, add in Gradle DSL for configuring essentially the same stuff that you would configure inside Maven or Ant for the library. And then the coolest part in my eyes was this progress logger, because if you use Ant or Maven, you just see megabytes of output that scrolls past the screen, say when you're running tests, especially in a large project. And you're never sure exactly where you are inside the build. And so this was one of the beautiful things about Gradle to me, was that you had this status line at the bottom that was constantly updated, and you knew exactly what task you were in the middle of running. But we didn't want it to have this long-running task. We wanted it to be like the integrated, or the Gradle test task that's built in. We wanted to have status as we went. So we used this progress logger so that we could use the same logging that Gradle test itself uses, so that we could give the status of which test we're currently on and how many suites have passed and how many current failed or skipped tests do we have, things like this. And so we added this output and it made our build output beautiful. So the next problem was integration tests. Like I said, the integration tests that we had built, they were in Maven, except they weren't in Maven, right? We built them in Ant because we had no other way to do it without writing a lot of custom Maven code. And so this got to the point where we were writing so much Ant, some of our developers, this is one of our founders, actually has this on his LinkedIn. He's an expert in running Ant from Maven. And so, so we wanted to get rid of this problem, and so we rewrote this entire setup inside Gradle, written as a Groovy plugin. The nice thing was that we could tweak the configuration per project, per Elasticsearch plugin or inside core anywhere. And it was much, much easier to reuse. Before, when we changed something in Ant, we actually had to copy a lot of the thing, because we had to re-implement, like, say, an entire task to start Elasticsearch. And so we had to copy that entire task and write a different version of it if we wanted to change or tweak something about that in Ant. With Gradle, this was nice because we could just add inputs for the things that we wanted to tweak and change them per project. And at the same time, we were able to add fixtures. So these were the things that we wanted to mock services with, and this was how we started on our road to really testing our plugins. Because while we had added things like class loader isolation, so that plugins were each running in their own class loader, so they couldn't mess with each other, we still weren't sure that they actually worked, because a lot of these plugins, if they're talking to an external service, if we don't have tests for it, how do we know that that code is executed at all? And this especially became really important when we added security managers. So in 2.0 of Elasticsearch, we had turned on the security manager for Elasticsearch because we wanted to make sure that we were not hijackable. We had some security vulnerabilities with execution through our script API that we wanted to avoid, and so security manager was the way we did that. But unfortunately with security manager, unless you're really running, you don't know that you're not just getting lucky because you're in a test setup that doesn't ever happen to execute, say, really talking to HDFS. And so these mocks were really important for that. We're still working on a lot of them, but definitely we have like an HDFS one in there now, which allowed us to actually work with our HDFS plugin for copying indexes over to HDFS. And if any of you have used HDFS, it's basically jar hell in a box. So it's really difficult when you want to integrate something in with their libraries. So the next thing that we wanted to do, so the last two things are things that we had wanted to do in Maven, but it was just really difficult. And so one was transitive dependencies. So transitive dependencies are central to Maven in how it works. You just pick up all the transitive dependencies of whatever you depend on, and that's what you get. But you don't really know what you're getting. And so in Apache Lucene for a very long time, because of the way Apache is structured, we really have to know exactly what we're depending on, because we need to make sure that we're not, say, accidentally depending on something that's GPL. And likewise in Elasticsearch, we wanted to know what we were depending on. And so Maven made this really hard. Gradle made it a lot easier. So there are various ways to disable transitive dependencies in Gradle. You can do it on a specific configuration or a specific dependency. We actually didn't want either one of those because if you think about it, so we have this core Elasticsearch jar, and it has some dependencies. And we didn't want those dependencies to be transitive. We wanted to know exactly what core was depending on. But now when a plugin depends on core, well, we want that plugin to be able to use the dependencies of Elasticsearch. And so we wanted to allow this one level of transitivity, but just with Elasticsearch, because we know that in our build, we've vetted those dependencies already. And so we were able to do this, thankfully, to the flexibility of Gradle. We added a handler that could essentially, every time a dependency was added, we could look at it and decide if we wanted to tweak the transitive flag on it. Now we still had to, we still wanted to publish a POM to Maven. We still wanted the system to work in Maven. And when we published that POM, we did some tricks to make it so that this turning off these transitive dependencies were reflected in the POM. They used to not be. I think in maybe 2.13 or 2.14, this is actually there by default in Gradle, but it used to not be. And so the last thing that we wanted to do was add modules in Elasticsearch. So what are modules? Well, this is what Elasticsearch core looked like. So if you looked at the API, it touched all over the place. We had just this big grab bag of spaghetti code for all of our different features of the platform. And we really wanted to separate this out and make it so core is this just central small little piece that had all of our APIs and essentially like a plugin runner, right? So that we have these central APIs that plugins implement, and then we wanted to implement a lot of our stuff through plugins. This was both for class loader isolation. It helped with dependency management so that we could have different implementations of things depending on different versions of dependencies. Helped with security because then we could enforce that one plugin can't mess with another. And so this is what we set out to do once we had switched to Gradle. And it turned out to be extremely easy. So what we did was essentially just reused the plugin. We made modules like they were plugins. So it was just a different set of sub-projects, and these used the same plugin API that we used in Elasticsearch. And they were simply, instead of being published to Maven where we publish our plugins, they were just dropped into our distributions when we build those distributions. Just adding cross-project dependencies, and it was really simple. We did it in less than a day in Gradle, and we needed to backport this because we had already split out some of these things, like some script engines, into separate plugins in Maven in 2.x. And so in order to backport this, it actually took about a week or more just to handhold through the crazy Maven, and then we had still Maven multi-module, so we screwed up all the time and accidentally CD'd into a directory because we had been using Gradle, and we were so used to being able to just run from anywhere. And so the process was extremely painful, but it allowed us to we finally backported this feature, and it was very, very painful, but Gradle was great. So those were the 5 of the things that we did, but it's not completely done. We still have more stuff that we want to do, and we have some things that we've learned throughout our 9-month journey now. So one of the things that we've learned is people still have this Maven mentality. So no matter what, there are still those people that love Maven and they think it's great, and they think that everything should be published. And this is a big problem. So if we look back at our 2.x Maven multi-module, and we had 60 modules or something like that, a bunch of these modules weren't actually projects. These were like test projects. It's like a module that just sat there with some test code so that it could test what happens if we pull in this plugin with Elasticsearch and run these HTTP tests on it. Now in Maven, there's no way not to publish that because Maven thinks everything should be a jar and everything should be published. But thankfully with Gradle, we didn't have to do that. Also with the modules that we had added, we didn't need to do that either because these modules were simply an artifact of our building our distributions. They weren't something that needed to be downloaded later or installed or anything like that, and so there was really no reason to publish them. Unfortunately, even now, this issue that I link here is only a couple weeks old, and there are still people that are saying, well, why aren't we getting these jars on Maven anymore? So it's still something that we're struggling through. Even had another issue the other day where a guy was checking out one of the old plugins when we had kind of a half-baked Gradle implementation in there, and he was on the wrong branch, and he said, Gradle doesn't work. Please add pom.xml, thanks. So it's a struggle to get people past this Maven mentality that everything must be published and everything is a jar, when really you should be able to have a project that may be just a collection of testing tasks or something like that. The next issue that we've dealt with is the Gradle Daemon. We actually disable this in our Gradle.properties. It's checked into our project. We've had issues with forbidden APIs. So forbidden APIs is one of those static analysis checkers that I mentioned. This, again, comes from Lucene. This is a tool written by a longtime Lucene committer that uses ASM to inspect the bytecode and find certain method signatures that we've listed out and said we don't want to use these. So for example, when using the file API in Java, it's very important when you're dealing with bytes and character sets that you don't use the default character set. You always want to know exactly what character set you're going to transcode between bytes, characters to bytes. And so this is really important that you don't use any of these file APIs that were in pre-Java 7, which do not take a character set because they depend on the file.encoding property. And so forbidden APIs has these default signatures as well as certain signatures for the JDK itself that you don't want to use. I recommend anyone interested in it go look. But so forbidden APIs, because it's trying to read the class files, we've had issues with it with the daemon. So when the daemon is turned on, some task is still holding on to a copy of the jar, and it gets touched, and then suddenly we can't load class files anymore from the jar. So there's an issue for it there. We've kind of have a workaround, but unfortunately that just disables the class loader cache inside Java. So we'd really not want to do that, but I was assured by some Gradle engineers that this is going to be fixed in 3.0, and they know about the class loader leaks. So hopefully that'll be fixed soon. The next thing is IDEs. So the original thing that caused us to move off of Gradle onto Maven was Ide Support, and it's still a problem. Maybe not as bad as it was back then, but IDEs are still stuck in this same Maven mindset that Maven users are. One of the big things is they still see main and test as this one thing, because you have one project that has main and test in it. While Gradle, in my opinion, has it right in that you have different source sets. So these are different pieces of code that can have different dependencies. And IntelliJ and Eclipse, IntelliJ is better a little bit, or they started getting better, but they keep breaking it. Eclipse, there's an issue that's like 5 years old or more in Eclipse for splitting out test and main, and I don't think it's ever going to get fixed. So there's just like fundamental problems in these IDEs that create circular dependencies. If you have, like we do, our core, then we have a test framework which depends on core, and then the tests for core depend on the test framework. So you have this jump, and so in like Eclipse, we actually have to split out core into like core main and core tests, essentially like two different projects when we're generating the project files for Eclipse. That IntelliJ issue there that I link is one of the recent breakages with IntelliJ. So hopefully it's getting fixed sometime this year. They say it's fixed there. Still not so sure. And the last thing is that Gradle is still in Flux. So we got bit recently, very recently, by a couple changes. 2.x, like I said, we started around 2.6, and this was going great. In 2.14, this progress logger that I said was so great for our tests, and we were able to capture Vagrant output and stuff like that, they considered it no longer part of the public API. And if any of you are following along, in 2.14, plugins no longer have access to internal classes. So they used to be kind of on the compile class path, but not the runtime class path. Well, now they're not there at all. And progress logger was moved away from the public API. So this is something we're kind of stuck on 2.13 until it's fixed. And then in 2.13, it actually broke console reading. So you could, for example, add some code that would run after the task graph is ready, and say if you need to input a password because you're about to publish. So you have upload archives or something like that in the task graph, and you want to make sure that your password is just loaded once, and you don't have to say have it inside a configuration file, because at many companies having passwords inside plain text files is no-go. So in 2.13 this broke, and the prompt just disappears, so it just hangs, and you're supposed to type in your password, and you don't realize that's what you're supposed to do, because that status line like overwrites it. But yeah, so Gradle is still in Flux. I'm very happy with a lot of the stuff that happened in 2.14. There's just still more work to do, and 3.0 looks awesome. So that's my talk. And have any questions? Yeah.
Well, how did you transform all those vehicles? Was it a manual process?
Completely manual. Yep. Yeah, thankfully a lot of the work had already been done in the move to multi-module because, like I said, a lot of it was cleaned up. We had parent POMs and everything, so there was much less configuration that we had to translate by that time. And it was just one by one, each plugin, like get core working, Gradle, okay, now let's add this plugin as a project. Iterated through it.
How about those plugins that exist in the Maven space that are perhaps not there in Gradle? I mean, did you manually implement like on-Gradle plugins? Did you implement them as, well, inline tasks? Or what did you do?
Yeah, so that's all inside our build source. So we set up build source, so that has the guts of our logic that we share across all of our core and our different plugins and tests and everything. And then we actually set that up as a kind of pseudo task that points into the source for build source so that we can publish that along with everything else. And then that way all of our external plugin authors can depend on that same logic. Yeah?
How much time will transition process take?
So, you know, I spent probably a couple weeks just on trying to get that testing framework set up alone. Once I had that set up and I had kind of core building, it was pretty quick to go through each of the plugins, although each plugin I would hit a new snag usually. So we got most of the work done in probably 2 months, maybe. But then there was a long tail of like extra static checker tasks and stuff. Even now, like for example, we still don't have some, I forget the code counting stuff. We still don't have some of those tasks in there, but you know, it's 99% there as far as what we had before. Coverage, thank you.
Are you missing a right in the angle brackets?
What's that?
Are you missing right in the angle brackets?
Am I missing right angle brackets?
XMLs.
Are you missing?
Oh, not at all. I mean, I'm not that huge of a fan of Groovy, but just the ability to add logic in there is something like, especially if I look at our Lucene build, in order to conditionalize something, it's so difficult and requires like, you know, okay, this property now sets another property based on this condition and stuff, and it's crazy. And when we were first doing this, so our master now is based on Java 8, but when I first started this, we still supported Java 7. And so Java 7, we would set permgen size, but in Java 8, you wouldn't. And so there was a crazy snippet of, you know, 30 or 40 lines of crazy Maven XML that would detect which version of Java it was running on and decide whether or not it was going to add in this permgen parameter to when we run tests, the setup for tests. And when I was first doing this, it was simply if Java 7 add permgen. So and it was, you know, went from 40 lines of XML to 1 line conditional. It's beautiful. Anything else? All right, thank you.